See here, so under node point, if a from a to b is an onto function, if f of a equals to b, range equals to codomain. If you use all, what is the codomain here? A comma b comma c. And what must be the range? If you use all the elements in second set, then only it will be onto. Okay, this is not onto anyway. So let us look at this example. LMN is the codomain and range is also LMN, means range codomain both are equal. Whenever you use all the elements in the codomain, then that is onto. Okay, so range equals to codomain. Range is that only, codomain is that only. So what is range here? L comma m comma n. Range is also L comma m comma n. So range equals to codomain. That is the main condition here. Now, so when function can be onto there, see here. Just have a look at that. In this example, so this is 1 1. No, different elements are having different image. No, here two elements are having same image, so it is not 1 1. Now is it 1 1? Yes, 1a, 2c, 3b, it is 1 1. And look at this example, 1a, 2b, 3d, this is d. Okay, so is this 1 1? Yes. Okay, irrespective of number of elements in second set codomain, that is 1 1 only. Different elements of A should have different images in B. Okay, so n of A less than n of B. In this case, we can make it as 1 1. Whenever n of A, n of B equal, then also we can make it as 1 1. Okay, because if you have 4 elements, for 4 images we need to have. Okay, so whatever number of elements we'll have in the first set, so same number of images we need to have in the second set. That's why n of A less than or equal to n of B. Okay, and n of A equal to n of B, n of A less than n of B. In both the cases, it can be 1 1. Clear? So now let us go to onto. Onto means every element of every element of Y belongs to B, there exists at least one pre-image X belongs to A, such that f of A equals to B, means range equals to codomain. If you observe this, what is codomain? A, B, C. Range is also A, B, C. Okay, so in this, what is image of 1? A. So f of 1 equal to A, f of 2 equals to B, f of 3, f of 4, C. Okay, so even though it is onto. Okay, every element of codomain should have at least one pre-image. Okay, see, every element of codomain A, B, C are having at least one pre-image. Okay, so here if you observe, image of 1 is A, that means pre-image of A is 1. Can I write f inverse of A equals to 1? Means pre-image of A is 1, reverse. Okay, so now, so when this happens, when this exists generally onto, whenever n of A greater than n of B, that can be onto. Whenever n of A, n of B same, in that case also we can make it as onto. See, here also every element of codomain having pre-image in A. So n of A greater than n of B or n of A equal to n of B. That means n of A greater than or equal to n of B. Now tell me, when can you say function as 1 1 and onto? Mean that is bijective. So when n of A equal to n of B. So this is only the case where a function is 1 1 and onto as well. Okay, actually 1 1 is known as injection, onto is known as surjection or surjective, injective, bijective. Clear? So whenever function is 1 1 and onto both, that is bijective function. Okay, so this is the types of functions, main types of functions. So now let us go to identity function now. Okay, now see, identity function. A function f from A to A is defined by f of x equal to x. Image of every element is itself. What is the meaning of f of x equal to x? Image of every element is itself. Image of 1 is 1, image of 2 is 2, image of 3 is 3, like that. Okay. Simply we can define identity function like this. A function which can be mapped from one set to itself. A function which can be mapped from one set to itself is known as an identity function. Clear? See, what is the condition? F of x equal to x. F of 1 is 1. See, for all x belongs to A. Correct? So every element must be mapped. Otherwise it is not function. Okay, we cannot leave any element. Which is not mapped to that. Okay. So if we take 4 elements must be mapped. Every element should be mapped to itself. See, f equals to a comma a, b comma b, c comma c, d comma d. This is also an identity function on this set. A, b, c, d. Clear? Now tell me, is this 1 1? Yes, because different elements of A are having different images. So it is 1 1 also. Acha, is it onto? Yes. How can you say it is onto? Every element of codomain having at least one preimage in domain. Okay. So in this case, identity function can be 1 1 and onto as well. That means identity function can be bijective function. Yes. See, every identity function is always a bijective function. Okay. So this is fourth type of function, identity function. Okay. So now let us go for next type, constant function. Meaning is there only, constant function. Okay. Means image must be constant. Every element of A domain should be mapped to one and only one element of codomain. Okay. You may have any number of elements in the domain, but you need to map all of those to one and only one element of codomain. So how can that condition for constant function? F of x equal to k. Okay. See here. A function f from a to b is said to be a constant function if f of x equal to k or f of x equal to c. Okay. Image of every element is constant, fixed. Okay. To whichever will map all the elements of A, that is constant, fixed. Okay. So